Hello and welcome everyone to your fourth and final online lesson. My name is Teacher Art and today's topic is number patterns and sequences. What are sequences? A sequence is a list of things, usually numbers, that are in a special order. Arithmetic sequences, for example, are made up by adding or subtracting the same value each time. So in the first example, we add 3 each time to get the next number. Second one, we add 5 each time. Third one, we add 6 each time. In a geometric sequence, we are multiplying by the same value each time. So instead of plussing by 3 and 3 and 3, we multiply by 3, multiply by 3, multiply by 3. And same in the second example. Triangle numbers is a sequence generated from a pattern of dots that form a triangle. By adding another row of dots and counting all the dots, we can find the next number of the sequence. Square numbers are the squares of whole numbers. So the first one, 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on. And cube numbers, similar to square numbers, but are the cubes of whole numbers. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, and so on. Fibonacci numbers are found by adding the two numbers before the number. So 2 is found by adding the two ones before it. 3 is found by adding 1 and 2. 5 is found by adding 2 and 3. And the 21 is found by adding 8 and 13. And the next number in the sequence would be 21 plus 34, which would be 55, and so on. A sequence usually has a rule, which is a way to find the value of each term. For example, the rule for an arithmetic sequence would be to plus or minus the same value each time. And the rule for geometric sequences would be to multiply or divide by the same number each time. What would be the rule for the sequence 3, 5, 7, 9, 11, and so on? The rule could be start at 3 and then plus 2 each time. The rule can help us to understand and to continue the sequence, but it will not help to calculate, for example, the 10th number in the sequence, or the 20th number, or the 100th number in the sequence. We could, if we wanted to calculate the 10th number, just carry on and keep adding 2 each time. So the next one would be 13. Next one would be 15, 17, 19, 21. I think that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 10th term is 21. We could then keep adding more numbers again until we get to the 20th term, and keep adding until we get to the 100th term. But that would take a lot of time. So instead of doing that, we come up with a formula for the sequence to help us to calculate any term in the sequence. So what can the formula be for the sequence 3, 5, 7, 9, and so on? Firstly, we can see the sequence goes up by 2 each time. So we can guess that the formula might look something like 2 times n. N is the term number we're looking at. So n would be number 1 here, number 2 here, number 3 here, number 4 here, and so on. So let's test that formula of 2 times n. Okay, our first term is 3. N is 1 over here. So 1 times 2 is 2, which is not the same as our term, but it's close. The second one would be 2 times 2, which is 4, which is also close. And the third one would be 3 times 2, which is 6, which is also close. But so we can see this formula 2n is not correct. But what if we were to plus 1 at the end here? 2 plus 1 would be 3. 4 plus 1 would be 5. And 6 plus 1 would be 7. So how about we try changing our formula to 2n plus 1. Now let's test that one. The first one would be 1 times 2 plus 1, which is 3, which is the same as our term. Second one would be 2 times 2, which is 4, plus 1 is 5, which is the same. And the third one would be 2 times 3 plus 1, which is 7. So that is our rule, our formula for this sequence. So now we can calculate other terms in our sequence. So we can get, for example, the 20th term by saying 2 times 20 plus 1, which is 41. And the 100th term, much faster than writing down each number in the sequence, we can just say 2 times 100 plus 1 is 201. Okay, let's try 2 more together. We can use the formula, the nth term is equal to a plus n minus 1 times d, where a is the first term in the sequence and d is the difference between each term, to help us to calculate the formula for an arithmetic sequence. If we look at this arithmetic sequence, 3, 5, 7, 9, 11, 13, the first number is 3. So a in this formula would be 3. The difference between each number is 2. So d is going to be 2. So if we use that formula, we will get 3 plus n minus 1 times 2. We multiply that 2 into the bracket. So we get 3 plus 2n minus 2. 3 minus 2 is 1. So our final formula here is 2n plus 1. And we can test that by saying 2 times 1 is 2, plus 1 is 3. So that's correct. 2 times 2 is 4, plus 1 is 5. Correct. And we'll see all the other ones are correct. Let's try 2 more. So if we look at the formula, a here is the first term, which is 1. D is the difference between each term. The difference between these two is 3. The difference is 3, difference is 3, so D is equal to 3. We put those into the formula, and we get 1 plus n minus 1 times 3. We multiply that 3 into the bracket, and we get 1 plus 3n minus 3. And 1 minus 3 is minus 2. So our final formula here is 3n minus 2. And we can test that again. We can say 3 times 1 is 3, minus 2 is 1. So that's correct. 3 times 2 is 8, 3 times 2 is 6, minus 2 is 4. So that's correct. 3 times 3 is 9, minus 2 is 7. So yes, we got the right formula there. Okay, let's try our last example here. 3, 8, 13, 18, 23, 28, so on. Our first term is 3, so a is 3. The difference between each number is 5, so d is equal to 5. We put those into the formula, and we get 3 plus n minus 1 times 5. We multiply the 5 into the bracket, and we get 3 plus 5n minus 5. And then 3 minus 5 is minus 2. So we're left with 5n minus 2. And let's test that. Here it would be 5 times 1 minus 2. 5 times 1 is 5, minus 2 is 3. 5 times 2 is 10, minus 2 is 8. 5 times 3 is 15, minus 2 is 13. So that's correct. Okay, so I've added some self-practice questions here for you guys to do by yourselves once you finish this video. So maybe write them down, or you can do them on the computer. And I've also attached some other worksheets regarding arithmetic, geometric, and Fibonacci numbers for you guys to do and to practice what you've learned about number patterns and sequences. Thank you guys. I hope you have a great week, and I look forward to seeing you guys soon. Bye-bye.